In this video, we are going to dissect word count or MapReduce again. So in the first basics course or in the basics track, we already saw what is MapReduce. In here, we are going to basically revisit that part with a more developer perspective. And then we'll be introducing two more advanced topics, partitioners and combiners, in this particular video. So let's get going. So let's talk about what exactly is MapReduce. So let's first start with the very basic example. So let's say we have 4 employees. Now, all these 4 employees have are supposed to work on every Saturday, and all of them decide that instead of wasting entire or working on entire Saturday, let's work for 2 to 3 hours, or let's say 3 hours. And after 3 hours are done, every week one guy will stay back and consolidate. So let's say they start their day at morning 8 o'clock. Till 11, everybody will do his own job. And after 11 o'clock, every weekend or every Saturday, one guy will stay back. So let's talk of this particular Saturday. So this Saturday we have John, David, Michael and Daryl, all 4 are in office. It's morning 8, 9, 10, 11. At 11, all of them are done with their work. And this week, let's say David is supposed to stay back. So in here, David stays back. So quickly let's reiterate. When everyone was minding his own business from 8 to 11, that phase is called as map phase. It's called as map phase. When David was, or everyone was done, and everybody would hand over his individual output to David, that process is called as shuffle. Now David would sort everything and create bucket, that would be called as sort. And finally, when David consolidates the whole thing, it's called as reduce. So as discussed in the first or in the basics track, MapReduce is nothing but some kind of divide and conquer. So right now all we need to concentrate is MapReduce is some kind of divide and conquer game. We will look at 2 more examples to basically make this understanding more concrete. We'll look at a couple of more concrete examples, and that's where we will introduce 2 more concepts, that's partitioner and combiner. So let's first start with taking one of the example. So let's say in a pack of cards, we have 52 cards. When you look at number of shapes, there are 4 shapes. And number of cards for each shape is 13. Number of cards for each and every shape is 13. So what we are supposed to do is, let's say we are supposed to write a MapReduce program that will count the number of cards for each shape. So what we are looking at is, we are looking at final output to be club 13, diamond 13, heart 13, spade 13. So club 13, heart 13, diamond 13 and spade 13. So let's look at how will we do this, or how will we achieve this in MapReduce. So let's say we have a file which is cards.txt. And let's say in the file we had data that looked like this is how the data looked like in the cards.txt. So now there are 52 cards out here, and let's assume that this was a 256 MB file. By default, the block size in MapReduce is 128 MB. So this 256 MB file would be cut into two pieces. So we have two pieces. So cards.txt is broken into BLK001 and BLK002. Now each block will be processed by a mapper. That's the map phase. It's a phase where every mapper is going to concentrate only on its own data. It's like minding our own business. So this mapper is going to concentrate on 26 cards, and this mapper is going to concentrate on its own 26 cards. Now the way mapper is going to function is it will look at one card at a time. So it will be basically looped through 26 times, and the output would look like so there'll be some 26 cards here and there'll be some 26 cards here. Now that's a base property of mapper, that it can only look at one card at a time. It can only look at one card at a time or one record at a time. So the mapper would now have, mapper 1 will have 26 records as output, and mapper 2 will have 26 record as its output. After both of them are done, or all the mappers are done, let's say in this case there was one reducer. So this 26 cards will flow here and 26 cards will flow here. So this act of throwing cards from mapper to the reducer phase is called as shuffle. Now before the final consolidation happens, there is a phase called sort, and sort is nothing but creating buckets. In this case there will be 4 buckets created. So there will be club, and all the ones will be together for 13 times. Diamond. So you have club, diamond, heart, spade, and buckets are ready. And finally, so this phase is called as sort phase. And finally in the reducer will take one bucket at a time, and its output would look like club 13, heart 13, and so on and so forth. That will be the final output of the reducer. So what we see here is mapper performs its operation on one record at a time, and reducer basically performs its operation on one bucket at a time. Now sometimes for non-programmers or people who are really beginning with programming, this can be a daunting task to understand what bucketing is or what sort phase really does. So let's understand what sort phase does. If this was to be a select query, we would say that this would look like select card shape, comma, count of star from cards table, group by card shape. So in here, if this was a query, this is precisely what we are trying to do. Now in this query, the number of output records we get, will be 4. That is club, diamond, heart, and spade. So what sort phase really does is it creates buckets of the unique records and brings all the values together. This is precisely what the sort phase does, and in the reduce phase you are consolidating the whole thing. So that is how MapReduce works. Now let's look at one more example for MapReduce to make the understanding more concrete. Post that, we will look at Partitioner, Combiner, and one more scenario. So let's get going. So let's take example that we have a file from Twitter. And the file has, let's say, 4 million records. The file is 512 MB. And file has data from, let's say, 90 countries. Now, our intention is to find number of tweets by country. That's the goal that we have. So the first thing we are going to do is we are going to dump twitter.json file, whatever JSON file we've got with 4 million records, and we'll dump that to HDFS. So that's twitter.json for us. And that's 512 MB. Broken into blocks, it will basically create 4 blocks of 128 MB. So hypothetically, each block will have 1 million tweets. So there are 4 blocks. Because there are 4 blocks, there'll be 4 mappers. So each mapper will process 1 block and hypothetically 1 million tweets. Now, if each block hypothetically has 1 million records, the map function will be called 1 million times, because map function can be called for 1 record at a time. So our output may look like and so on and so forth. So we have output from 4 mappers. We have output from all the 4 mappers, and that's where we'll introduce a shuffle. So we have one reducer or one reduce phase where all the data would get there, and there'll be 4 million records. This phase is shuffle phase. This phase is shuffle phase. Now, when you have 4 million records, in the sort phase, this will be basically 90 buckets. And the buckets would be sorted as based on the tweets. And finally, in the reduce phase, reduce will take 1 bucket at a time. So reduce function will be called 90 times, and it will summarize and give us stuff that look like and so on and so forth. This is how MapReduce really works. So mapper operates on 1 record at a time, and reducer operates on 1 bucket at a time. Now let's expand this a bit further and let's understand how this really works. Let's take this example and expand this further. and we will understand how this technically really works. So let's take the same example. We have data here called as twitter.json, and it's already broken into blocks. Now that it's already broken into blocks, when you submit your program, your program actually tries to create something called as input splits based on input format. So what exactly is an input split? Now when you have BLK 001, 002, 003 and 004, there is no guarantee that everything is gracefully broken. So block is nothing but an illogical 128 MB file, and input split is a logical file. So it's decided based on your input format. So let's say we decide that it's a JSON file. So we will create a JSON file format and then define what is a logical end. So based on that, what would get created is, out of these blocks, what we will get created is input splits, something like so this is like there is some overlap. So that's BLK 001 plus, let's just say for the logical ending, it is 300 bytes. And it starts from BLK 002 plus 300 bytes. So we've already lost 300 bytes. To let's say BLK 003 plus 990 bytes. So this is logical right now. So this BLK 002 is actually overlapping. The third one starts from BLK 003 plus 990 bytes to BLK 004 plus 1 byte. That's like overlapping. And input split 4 is nothing but BLK 004 plus 1 byte to end. So how this really works is input splits define, or input format defines that what is a logical end. So this is input split 1, input split 2, input split 3, and input split 4. So now we have 4 input splits. BLK 001 is illogical. That means at 128 MB it will get cut. Maybe logical, may not be logical. But input split 1 is BLK 001, that's illogical, plus 300 bytes, which will make it, let's say, logical. So right now what we have is 4 input splits which are absolutely logical. Now mappers will operate on them, but the important point is before mappers can have him or have them, there is an interesting class called as record reader. Record reader is basically a class that will read one record at a time. that will read one record at a time and pass it on to Mr. Mapper. And after that, the whole process remains same, that you have a shuffle, sort and reduce. So it's the same shuffle, sort, reduce. This is how technically MapReduce works from the developer's perspective. But when it comes to coding, as a developer, you're primarily supposed to write just your mapper code and the reducer code. Your entire focus has to be writing business logic for mapper and reducer and nothing else. So this is how MapReduce works. Now, so far, whatever we've seen, we've always assumed that there is only one reducer. There is only one reducer, which is actually a problem. Let's understand this. Let's understand this with some more detail. So we have 4 employees. 4 employees are equivalent to, let's say, 4 mappers. Now, once all 4 are done, let's say David stays back and David is kind of the reducer. Now, 4 mappers being there and 1 reducer sounds fair, but what if there were 600 employees in office? Or what if there were 600 mappers? Can 1 reducer do all the consolidation? That's not really possible. So the point is, by default, when we install Hadoop, the number of reducers is 1. It's okay for few mappers, but as your mappers grow, it's impractical to have just 1 reducer. So now what we are going to talk about is how can you go about having multiple reducers, and if you have multiple reducers, how the entire game changes. So let's talk about multiple reducers. And in this particular example, when we talk of multiple reducers, we will get introduced to a concept called as partitioner. So let's understand this. Let's reiterate back to the cards example. So cards.txt has 52 cards, and let's say there are there are 2 mappers, each mapper taking care of one block. So what we get is 26 cards and 26 cards. Now, if we had only one reducer, the mappers could very well throw everything to this reducer, and that was fairly straightforward. But let's say in this example, we don't have one reducer, but let's say we have 4 reducers. So instead of one reducer, now we end up having 4 reducers. When you have 4 reducers, these mappers now need to have some logic of how to send data to whom, or how to send our data to which reducer. So it can't be blind the way previously it was. And that's where comes a component called as Partitioner. Partitioner is kind of a component that tries its best to be a load balancer. It's kind of a component that tries its best to be a load balancer. So Partitioner would apply some logic so that some cards go here, some go here, some go here, and some go here. Here also Partitioner will try its best to occupy all the reducers. Now the real question is, on what basis will the Partitioner decide which key value pair should go to which reducer? There is a generic formula for that, and the generic formula is key.hashcode modulo number of reducers. This is the generic formula to decide which key should go to which reducer. Let's take an example. So let's say club.hashcode was 80. 80 modulo 4 is 0. So all the clubs will travel to reducer 0. Let's take example that diamond.hashcode was 81. So all the diamonds would end up traveling to reducer 2. And that is how it's decided which reducer will get which key. Now if the number of reducers are 4, the possible outcome would be 0, 1, 2 and 3. If number of reducers were 8, the possible outcome will be 0 to 7. That is how a generic partitioner would work. So in the best case, partitioner would have given 13 cards to each one of them, and that is how it works. But partitioner works on a generic hashcode formula, and we don't really know what is hashcode. So assuming that in our case club.hashcode was 80, diamond.hashcode was 84, heart.hashcode was 88, and spade.hashcode was 92. If this was the case, all the data would have ended up only with reducer number 1. So that's the point. By default, let's reiterate this. By default, MapReduce uses hashcode partitioner. By default, MapReduce uses hashcode partitioner. But cases where hashcode partitioner does not work or does not perform, as a developer, you are free to customize your partitioner. As a developer, you have complete authority to customize your partitioner. In the previous case, we saw that partitioner was okay, just that it was not performing. In some cases, we will be seeing that default partitioner will not at all work, and you're free to basically override the partitioner. This is how the partitioner really works. This is an interesting moment where we should just divert from the topic, and let's quickly summarize something very important. Before that, let's quickly talk about it. In the previous case where we had 4 reducers, we will have 4 output files. So there's a command called get merge, which will merge output from all the 4 files. So this is how MapReduce would do work when you have partitioner. So let's quickly reiterate the fact and how things work for MapReduce. MapReduce behavior. If number of reducers is greater than 0, if number of reducers are greater than 0, number of output files is equal to number of reducers. Output of reducers is returned to HDFS because that's my final. Interestingly, output of mapper is written on local file system. That's very important. See, once we get our reducer output, we really don't need our mapper output. That is why there is no point in breaking the mapper output into blocks and replicating it 3 times. That's why we will have absolutely no interest in storing mapper output on HDFS. It's directly stored on local, and deleted after the job completes. If number of reducers is equal to 0, so there could be cases where we don't need reducer at all. A classical example would be, let's say we have 100 JPEG files or PNG files and we want to convert them to 100 PDFs. We are not consolidating anything, so there could be cases where we don't need reducer at all. And in cases where we don't need reducer at all, we can always go back and say that the number of reducers that we want for this particular job are 0. Once we do that, number of output files will be equal to number of mappers. Output of reducer is not applicable, and output of mapper this time will be final output. That's why it's HDFS. It's directly returned to HDFS. So this is how MapReduce works. So a quick iteration of entire MapReduce. MapReduce is a processing framework that distributes the tasks across the machines, works kind of a divide and conquer methodology, In mapper phase, so before the mapper phase starts, when you give your file is broken into blocks, and the input split is calculated based on the logical input format. So let's say a block is illogical 128 MB and input split is logical 128 MB plus wherever there is a logical end for that trailing record. Input splits are then read by record reader, and record reader would read one record at a time. Once record readers read one record at a time, each record is passed to the mapper. Mapper will perform operation on one record at a time, so that's kind of the divide phase, and mapper will give output of one record at a time. Once all the mappers are done, all the output is thrown to a shuffle phase. Shuffle is a phase where output from mapper is thrown towards the reducer phase. In the reduce phase, first thing what happens is you have a sort. So all the data that comes from the mapper is sorted and buckets are created. And once buckets are created, you have the reduce phase where it takes one bag at a time and processes the entire bag of information and gives us the result set. This is how MapReduce works. By default, when you install Hadoop, the number of reducers is always 1. For a small POC, this is perfect, but as your cluster grows and as your processing grows, you can't have so many mappers and one reducer consolidating the whole thing. That is where you can have multiple reducers. As soon as you have multiple reducers, you would require something called as partitioner, which is by default there. Partitioner, its intention is to load balance the data that comes out of mappers among the reducers that are out there. The generic formula that partitioner uses is called as hash code partitioning. With hash code partitioner, what it does is it just takes hash code of the key and does a modulo with number of reducers. For example, if number of reducers are 4, the possible outcome of a modulo operation will be 0, 1, 2, and 3. That's the only possible outcome. Once the modulo is calculated, the data is passed to that particular reducer. Now, by default, hash code partitioner would do perfect job, but a lot of times you may not be happy with the performance because of modulo, the load balancing could be slightly wavered. So you are free to write your own partitioner. Sometimes your business logic would demand that you write a separate partitioner, and you can do that also. So partitioner is by default hash code, works on hash code, but as a developer, you are free to override it. This is what we've seen so far. And the last iteration or the last important summarization is, now as a developer, you can decide number of reducers. If you decide number of reducers to be greater than 0, the number of output files will be equal to number of reducers. Output of reducers will be returned to HDFS, and output of mappers will be returned to local, and as soon as the job is done, they'll be deleted. If the number of reducers is equal to 0, then number of output files will be equal to number of mappers. Output of reducers does not apply, and output of mappers is directly returned to HDFS. This is how you go about doing MapReduce. Now there is one important concept that we need to discuss called combiners, and after that you will be ready for designing MapReduce applications. So let's now talk about what exactly is combiner. So let's talk of the card count example. So we have a file called as cards.txt. Cards.txt is a file which has, let's say, 52 cards, and it's 256 MB in size. So let's say there are 2 blocks. So you have BLK001 and BLK002. Then mappers will operate. So this mapper will give 26 cards out. If you could just put it club, diamond, some 26 cards and some 26 cards here. Now totally 52 cards are flying across the network. 52 cards are flying across the network for the shuffle phase. So the number of cards that are flying are 52 cards. And then there is a sort and reduce. Now if you carefully look at the data, you might feel that we should do something about the network traffic. We should do something about the network traffic. And that's where you can have a mini reducer called as combiner. A combiner is nothing but a mini reducer and what combiner would technically do is what reducer does on the entire data, combiner will do it on the mapper data. So what combiner would give output may look like and here combiner may give output that looks like this is how combiner would reduce your network traffic. So instead of 52 cards with combiner in action, we will simply be transporting only 8 cards if combiner was there. So combiner is there to reduce the network traffic from the mapper phase to the reducer phase, and it kind of acts as a mini reducer. So this is how entire MapReduce really works with combiner and partitioner. So let's bring everything together in one diagram. And once we have that diagram, we'll then talk about one example which will cover all the aspects of partitioners and combiners. Then we'll move to the assignments. So let's get going. So it all starts with your input file. Input file is broken into blocks which are illogical. So let's have them rough. So input file is broken into block, BLK 001, 002, 003 and 004. Then based on the purpose, let's say you want to do a group by, you submit your program. Let's keep it as a Java program. The first thing that happens is you have something called as input format class. It's a Java class that will convert these blocks which are right now rough into smooth blocks, or something called as input splits, and they are bound to overlap, absolutely natural. So let's say there are input splits. Once input splits are calculated, we are now supposed to have a record reader class which will read one record at a time. So record reader is out here to read one record at a time, and that gets passed to the map phase. So there'll be 4 mappers in this case. After map, there is an optional phase called combiner. There is a phase called partitioner. And then there is shuffle and reduce. Mapper phase will read one record at a time and perform processing on one record at a time. Then there is optional combiner. And there is not optional, compulsory partitioner. This phase of pushing data is shuffle. And finally here you have this is how entire MapReduce framework works. This is how entire MapReduce framework works. Now let's look at one example which will bring everything together, be it mappers, partitioners, combiners, and reducers, and that will set the stage for our assignment. So here we are going to look at 2 examples. These 2 examples will basically demonstrate entire MapReduce framework that we've seen, and it will reiterate the whole concept. And in the next video, we are going to look at the assignment that you're going to do for designing MapReduce programs. So let's get going. So the first problem we are going to talk about is denomination value. So we have 4 brothers. So we have four brothers: David, John, Michael, and Daryl. Father brings in 16,000 notes, checks of $1, 2, so father brings in checks of $1, 2, 5, 10, 50, and 100. What father really wants is value for each and every denomination. So when we say value for each and every denomination, what we are talking about is so if there are 1,000 notes of $1 denomination, then the value of $1 is $1,000. It's $1,000. But what father wants is David should report value for $1, 2, 5, and 10, and Daryl should report value for 50 and 100. So let's look at how we will do this in MapReduce. So far from the example, one thing is clear, that number of mappers are 4, and the mappers are David, John, Michael, and Daryl. These are the 4 mappers that we have. Number of reducers are 2, David and Daryl. David should give denomination value for 1, 2, 5, and 10, and Daryl should give denomination for 50 and 100. So now let's look at how will this really work, and there are 16,000 notes or checks. So let's start with the example. So there are 16,000 notes or checks. There are 4 brothers. So each one gets around 4,000 checks. Each one gets around 4,000 checks. Now the way each brother will process it would look like there'll be some 4,000 pairs. So brother 1 will give 4,000, 2 will give 4,000, 3 will give 4,000, 4 will give 4,000. End of it, David and Daryl are supposed to consolidate. So this is David, and this is Daryl. But the point is, if you use hashcode partitioner, there is no guarantee on what hashcode is going to come. So let's look at this. Imagine $50 modulo dot hashcode happens to be 90. 90 modulo 2 is 0. So that kind of violates the goal. If we go by hashcode partitioner, in this case, David may end up receiving $50. That's something we don't want. So what we will really require is a custom partitioner. And the logic for custom partitioner, let's look at that. So this is a clear case where hashcode partitioner may not satisfy your condition, and that's why you will use a custom partitioner which would look like if dollar value is less than 50, go to David, else go to Daryl. So this is the partitioner which will do the job for us. So this 4,000 pairs all are here. Now what David gets as input is something like $1, 1111111, $5, so anything that's less than 50 will be given to David, and anything above 50 will be given to Daryl. And what you finally get out of in the reducer, they'll multiply and say that $1, the denomination value was and so on and so forth. This is how things will work. Here what we saw is that's what we've seen. Now this was an example. So that's why what you see is you get $11111 everything. This is how it works without a combiner. Now let's look at what happens if combiner was introduced. Let's look at what happens when combiner was introduced. If combiner was introduced, the whole thing remains completely same. Just that here there will be a mini reducer that will consolidate all the $1s, for example, and come up with, let's say there are 2,000, $2, there are, let's say, 100. So each reducer or each mapper will have a mini reducer, and in here what David may get is And what David just needs to do is perform this addition operation 4 times and get the value. So with combiner, instead of everything coming as 1, 1, 1, the mini reducer will take care of consolidation on the mapper side itself, and what you get is direct values from each mapper. In this case, there'll be just 4 values. This is how the entire thing will work. This is with combiner. So what we've seen is how would MapReduce work without combiner, and how will MapReduce work with combiner. Let's look at one more example from a perspective of combiner and when it can be applied and when it cannot be applied, or how it can be customized, and then you're ready for the assignments. So the next use case we had was average by city. Average by city. So let's say we have a case where there are some financial transactions. And the financial transactions also have city. They also have city. What we really want is we want to calculate the transaction by city. That's the average transaction. So what we really mean is, let's say we have San Francisco, there are, let's say, 4 transactions. So the total transaction size is 16,000 divided by 4. So the average transaction is 4,000. So what we want is average transaction by city. Average transaction by city. So let's first do it without a combiner. We'll have mapper. So the output of mapper would basically be city comma amount. And in the reducer, what we get is city comma amount 1, amount 2, amount 3, amount 4. And in reducer, we will do sum of amounts divided by, in this case, 4. And that's how we get average. But then if you put combiner, the situation can change. Let's take an example. Let's take a hypothetical case. Let's say there are like this 17 amounts. So let's say mapper 1 got any 4 amounts, mapper 2 got 4 amounts, mapper 3 got 3 amounts, and mapper 4 got 6 amounts. So in our combiner, we will be doing an average. So that will be sum of amount divided by 4. Here also it will be sum of amount divided by 4. Here it will be sum of amount divided by 3. And here it will be sum of amount divided by 6. So what you get is 4 amounts. Because there are 4 mappers, you will get 4 amounts, and you will sum that or divide that by 4. But this is not gonna work. Let's understand why. Let's understand why. Sum by 4 plus sum by 4 plus sum by 3 plus sum by 6 is not equal to sum by 17. With combiner, what we ended up doing is average of average. The point is, combiner is awesome, but it's optional and cannot be directly implemented Combiner is awesome, but it's optional and cannot be directly implemented if the operation is not commutative and associative. Addition is an operation, no matter where it is done, the output will be same. Be it 2 plus 3 plus 3 plus 2 or 5 plus 5, the output is going to be 10 all the time. But we cannot say the same thing about average. If the denominator changes, you will not be able to perform average. That is why combiner can be used out of the box or just the way it is if the operation is commutative and associative. If it is not commutative and associative, then you will have to customize the combiner. In this case, had you written a correct combiner, we could have simply done correct combiner could have been just performed the sum from each and every mapper, and here it could have been sum of amount by sum of counts, and that would have given you the output. So combiner is optional and cannot be out of the box implemented if the operation is not commutative and associative. So that is how you can use combiner. So now, quick summary of what we've seen. We saw what is mapper, we saw reducer, we understood shuffle, we understood sort, we understood default partitioner, combiner needs tweaking. This is what we've seen so far in this video, and in the next video we are going to look at the assignments.